All right, chapter 10 done. Test done. I hope it wasn't too bad. It wasn't intended to be. I'm sure the grades were great. And now we can move on to chapter 11, which is about area, 2 dimensions. We're going to talk about all sorts of polygons, but we're going to start here in chapter 11, section 1, with just triangles and parallelograms. So let's get started. This lesson is going to seem basic, but once you start digging into the homework, you're going to realize there's a lot to it. So I'm hoping you watch this video, get through it quick, and then really start doing those homework problems because I made 11.1 a little bit of a longer assignment. So you're going to have a lot of practice on this, and it's going to really set the tone for the rest of the chapter. So get started right away. All right, here we go. Starting off, area of a rectangle. I don't know about you, but I think I learned this in like 6th grade, where we wanted to find the area of a rectangle. And I can remember being given some sort of handheld toy that was a rectangle but broken up into little squares. And they said count the squares. So I probably sat there as a little 10 or 12-year-old and counted them all. And then we had to figure out, well, what's a good way to figure it out without having to count them all? And the conclusion that we came to as a 4th, 5th, 6th grade class, whatever it was, is that if you count how many across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 across. I'm just going to draw that up here. And how many high? 1, 2, 3, 4, 5, 5 high. That instead of counting them all, we could just say, well, there's 12 columns of 5 or 5 rows of 12, and 12 times 5 is 60. All we had to do is multiply the length times the width, is how we called it when I first learned it. Area is length times width, and that works for a rectangle. Here, we get in geometry, we don't use the terms length and width as much. Base and height is what you generally see it called. And in a rectangle, you can call one side the base, the non-congruent side or the non-opposite side the height, and you could just multiply it. And that'll tell you how much space inside that rectangle there is. So if there was 12 squares this way and 5 square this way, there is 60 squares total. 60 square units. So what are we going to do with that? Well, we're going to start talking about parallelograms. And as you remember from our quadrilateral chapter, a parallelogram is any quadrilateral where the opposite sides are parallel. And if you think about it, and I guess you don't have to think about it because I already have this animation here, a parallelogram is simply a rearranged rectangle. There's the rectangle, but let's get it to start back over. Parallelogram. It's just if you chop off that extra part of the parallelogram, move it there, it just makes a rectangle. So we can use the same formula for a parallelogram that we can use for a rectangle. It's just base times height. The only difference is in a parallelogram, the base and the height may not be the sides necessarily, but you can still multiply the length of the base times the height of the parallelogram to find the area. The way I think about it, and you'll see this, you saw that formulas on the next slide, but area equals the base times the height, just like in a rectangle. The base can be any side of the parallelogram. The height, though, has to be the perpendicular distance between the bases. Does not have to be a side. If I rearrange it to form a rectangle, it would be a side, as you see here, but really I just need that perpendicular distance between the two sides and do base times height. So there's our textbook version of the formula. And here's our first example. Find the area of PQRS. So I'm going to do area equals base times height. As I said, the base can be any side. So if I wanted, I could use this 12 as my base. Here we go. There's my base of 12. And the height is the distance between the two 12s. So that's this 4. So I could do 12 times 4 to get an area of 48 square units. We're always going to use square units for area. we're talking about space. Well, that's not the only way I can do this one with the information. If I wanted to, with the information I was given here, if I wanted to find the area of this parallelogram, this blue parallelogram, I could also use the 6 as my base because the 6 is a side. Now I just got to make sure I use the perpendicular distance between the two 6 like bases with length of 6. And I've actually been given that. That 8, which I'm going to highlight here, just a little red marker. Reset again, huh? That 8, that length RU, well, that's the distance between the two 6's, the perpendicular distance. You can see the right angle, and I think you could tell from the way I'm moving it that that's how far apart the perpendicular distance between those two purple lines of 6 in length. So I could do 6 times 8 also. Same result, 48 units squared, which makes sense because I'm trying to find this same blue area. Moral of the story, area of a parallelogram is base times height. The side can be any, or the base can be any side as long as the height is the perpendicular distance between those pairs, those congruent sides. So here's an example. They're asking us to find the area of this parallelogram. I have the 8 is what is this side, which means this is an 8. This is a 10, this is a 10. And now they're asking me for the area. Well, I would choose wisely which side you use as your base. If area is base times height, I could technically try to use the 8 if I had the perpendicular distance between those 8s. That would look something like this. Perpendicular distance between the 8s would be something like that. And I don't seem to have that, but I do have the perpendicular distance between these 10s, or at least I have a line drawn in. And I would say with this 45-degree angle, I could easily find that using my special right triangle, 45, 45, 90 rule. And as hopefully you remember that in a 45, 45, 90, the two legs are congruent because it's an isosceles triangle, and the hypotenuse is √2 times that leg. So if I want to find the leg, I'll just divide by √2. And 8 divided by √2 is 4√2. So now I could say that the area of this parallelogram is 10 centimeters times 4√2 centimeters, which gives me 40√2 centimeters squared. And that is the area of this parallelogram. Next, we're going to talk about triangles. We can use the parallelogram area formula to find the area of a triangle. And as you can see from this animation, there's a parallelogram. It's made up of two congruent triangles. So if I wanted to use that same idea of area equaling base times height to find the area of a parallelogram, well, I could just cut it in half to find the area of one of those triangles. Therefore, the area of a triangle formula is base times height divided by 2. Sometimes you see it written as half base times height, which is often how I write it. But hopefully you realize those are the exact same thing. And you can see right now, two same triangles pushed together form a parallelogram. So I can use that same formula, but still the height has to be that perpendicular distance between the two bases, which in this case means for the triangle, it means that it's going to be the perpendicular distance that hits the base from the opposite vertex. It's the altitude from the base to the opposite vertex. You can use any of the three sides of the triangle as your base as long as you have the altitude to the opposite vertex to use as your height. There's your formula right there. Area equals base times height, or half base times height over 2, which is half base times height. Any side can be your base as long as your height is perpendicular to it. A couple different kinds of triangles you might see. This appears to be like an acute triangle. Keep in mind that in a right triangle, just do this. In a right triangle, well, if I wanted to use this as the base, I could use the perpendicular side as the height. Or if I wanted to use this as the base, I could use this perpendicular side as the height. But if I wanted to use this as the base, well, now I would need this altitude here to use as my height. So in most right triangles, I would just use the two perpendicular sides as your base and height. And then in an obtuse triangle, ooh, that didn't work. In an obtuse triangle, if I wanted to use this as my base, well, now I have to find that altitude. And remember way back to that chapter 5, where we talked about all the different special segments in triangles? My altitude would sometimes have to drop outside the triangle. So to find the area of this triangle, I may have to use this height that is perpendicular to the base. The altitude to the opposite vertex doesn't necessarily have to be in the triangle. If you remember, the orthocenter can sometimes be found outside the triangle. Well, the height can sometimes be outside the triangle, so just keep all that in mind. Here's a couple examples. Let's give them a try. And it looks like that's going to be the last slide, so let's do this. The base of a triangle is twice its height. The area is 36. Find the base and height. Well, area is base times height over 2. And if the base of the triangle is twice the height, well, I'll use h equals height. And then if the base is twice that height, I could call the base 2 times the height. And I can plug into this formula where the area is 36, and I can do the height, or the base, which is 2h, times the height, which is h, divided by 2. So I can get, I'm just going to go over here. I could get 36 equals 2h squared over 2, which I would cancel out the 2's. And then I could get that the h is equal to 6 inches. Keep in mind that I don't want to give plus or minus in this case, even though negative 6 squared is also 36. A height is a distance, and we're always going to think of distances as positive. Here's a little step up to find the area of an equilateral triangle with the side length of 6. Those aren't units, that's multiple exclamation points. I think I really wanted to emphasize this question. Well, if the side length 6, I can draw those in. And now we could use a little trick that we talked about, or a little property of equilateral triangles, is that they're also equiangular. So if all the sides are equal, all the angles are equal, and of course 180 divided by 3 is 60. So I know each angle is 60 degrees, and now I can very simply drop in a height to any of the sides. I'm going to keep it simple and draw this altitude right here. And I recall from chapter 5 also that in any isosceles triangle where the segment is drawn from the vertex to the base, it bisects the base. It's also a median, making that 3. And now I could use Pythagorean theorem, or more easily, and hopefully you thought of this right away, is use my 30, 60, 90 rule to find that the height is 3 root 3. And hopefully by now, anytime you're seeing those special right triangles, you're defaulting to using the rules that we talked about, those special right triangle rules, before you start doing anything that's going to result in non-exact answers. As soon as I saw that 60 in that right angle, I knew I was going to use that special right triangle rule, and I hope you're doing the same thing. But either way, I'm going to do area equals half base times height. So if I use this 6 as my base, I can now use this 3 root 3 as my height, and I'd probably do half of 6 is 3, and my area equals 9 root 3. And since I wasn't given any units, I'll just call it units squared. All right, that's going to wrap up the first section of chapter 11. Like I said, there's a lot going on in this homework assignment. You might want to take a few sittings to do it. So I'd say the sooner the better you get started, the better off you'll be. And I'm hoping to be in for extra help on Thursday afternoon at around 4 o'clock. And then we'll have a live session next Monday. I can't remember the time, but it is posted in Schoology. So I hope to see you all at Monday, or at least by Monday at the latest. Stay healthy.